Hi static engineers, welcome back. In today's video, we will discuss about how we are going to choose the material for ASME pressure vessel design. So in this video, I will tell you how to choose the material and where to choose the material and what are all the important factors before choosing the material. Those things we will discuss. First, why material selection matters. It matters because of strength, safety, corrosion resistant and cost. If we choose the wrong material, then the vessel will fail. So the material selection is very much important for any static equipment engineer. If you are working in ASME vessel or EN vessel, in any vessels, the material selection is very much important. Before starting this video, I need to tell you that the material selection, most of the times it is selected by the process engineer or the client, but sometimes it comes to your table. Most of the times in specification they have mentioned it as CS material, carbon steel material. There are many carbon steel materials. In those materials, which material we have to select for the particular vessel, we are the deciding authority for that. If you see this video, you can get that knowledge, so you can able to pick the material, pick the right material for your particular pressure vessel. Before selecting the material, there are two different codes we will choose the material. One is ASME code and another one is ASTM code. ASME, you already know, the abbreviation is American Society of Mechanical Engineers, and for ASTM it is American Society of Testing Materials. Now we will see what are the differences between ASME and ASTM. First we will see about the ASTM. In ASTM, almost there are thousands and thousands of material are listed under ASME, but in ASME it is not number of materials, there are also many materials, but comparing to ASTM, quantity of the material will be very low in ASME. In ASTM, it provides almost all the details of the material, from testing to chemical compositions to everything. It is listed in ASTM. But if you go to ASME, it provides the allowable stress and how the material will react for the particular pressure vessel. It is mostly based on pressure vessel. Only for the pressure vessel the ASME materials are listed, and for ASTM not only pressure vessels, almost all the materials, all the equipments we can able to refer in ASTM. Actually ASTM is a international standard for all the materials, but for ASME it is only for pressure vessels. If you are using a material from ASME to design a pressure vessel for ASME section 8 division 1, the AI will directly approve the material. If you are choosing the material from ASTM, sometimes the inspector will ask for what is the alternate material you can able to use in ASME, why you have not used ASME material, you have choose ASTM material. Those questions will be raised, but most of the time if the AI is a experienced guy, if the AI has seen more pressure vessels, then the questions will be low. If the AI is new to the particular field, then there will be some more questions, so we have to be prepared for that question. As I already told, we are choosing the ASME materials from ASME section 2. There are almost 4 parts. You can able to see part A, part B, part C and part D. Now we will see what are all the parts for. For part A, it is for the ferrous materials, it is for the steel and iron material, that will be come under part A. If the material doesn't has Fe, like copper, aluminum, those kind of non-ferrous materials will come under part B. And part C is for consumables like welding rods, electrodes, pillar material, those are all come under part C. And for part D, it is fully for the property of the materials, like allowable stresses will be listed there, yield stresses will be listed there, and ultimate tensile strength will be listed there. Those kind of values and some charts also there, you can able to get it part D. And it's a important rule that you have to use ASME certified materials, that means ASME listed materials. If you are taking a random material and doing the design for ASME, it is not allowed, it is directly rejected by ASME engineers, I mean the AI or any authorized inspector. If I choose any random Chinese material or any other material, you get it from a local shop and you manufactured a pressure vessel using that material, and while it goes to the ASME engineer approval, that means authorized engineer approval, they will reject the material, they won't consider it as a pressure vessel. So you have to be very careful while designing, while picking the material. You are the only responsible for the material. Okay, so you have to be very responsible. I have taken one material from ASME which is SA516 grade 70. First, what is SA, what is 516, what is grade, and what is 70. I will explain this. SA516. Actually, this SA is, here you can able to see, it is a ASME approved material. This material is adopted by ASME standards. Actually, the S stands for approved by ASME, and 516. The 516 stands for it is a form of the material. How the material is. If it is a pipe, then it must be 106. If it is rod, it is 497. Plate, it must be 516. It is a product form. How the product will look like, and the grade. Here it is simply the grade, and it is 70. It is directly mentioned the grade of the particular material. If it is 60, if it is 50, if it is 55, then the material grade has reduced, and if it is 70, it is a good material. The takeaway is, if the material has SA in the wording, then it must be a approved material by ASME. Also, there is another one difference: SA516M and SA516. That means SA516 grade 70 and SA516M grade 70. It is a simple thing. It's a very simple thing. SA516 means it is a imperial unit material, and SA516M means it's metric unit material. The thicknesses are given in the inches for the imperial units, and thicknesses are given in mm for the metric units. And the stress levels also given as PSI or KSI. In metric standards, it is given as MPa. Okay, so everything remains same. The material chemistry remains same, the material strength remains same, the material form remains same, everything remains same. Only the change is the unit system. Here we comes to the selection factors. What are all the important factors before selecting the material we have to consider? The first one is design temperature, allowable stress, corrosion, and fabrication. How the design temperature influences the material selection? The design temperature is directly linked to the material selection, because if the design temperature is too hot, some materials can't able to withstand the extreme hotness, and some materials can't able to withstand the extreme coldness. So we have to choose the material according to the temperature. And allowable stresses. We have one pressure vessel. We have to choose the material for the pressure vessel. There must be some strength requirement of the particular material. If the strength requirement is not sufficient for that particular material, we have to choose another material. That is the allowable stress. And corrosion. Actually, this one plays very important factor during selection of material, because if the process has corrosive liquid, we have to choose the material accordingly. We have to choose the stainless steel material, or we have to choose lining for the carbon steel, or we have to choose any other different alloy material to reduce the corrosion. Normally, corrosion occurs in different ways. One is the normal corrosion, which occur due to the acidity pH level of the particular process liquid, and FAC, the flow actuated corrosion, that is also there. There are many types of corrosion. We have to choose the material according to the corrosion allowance. If the corrosion is too much, we have to choose SS material or any other good material. Finally, fabrication. How fabrication influences the material selection? As a static equipment engineer, as a designer, you need to know, you need to think in the foot of fabricator, because we are going to manufacture using a fabricator. If the fabricator doesn't have that capacity, you have chosen a 60 mm or 70 mm thickness for a hemispherical dish shank. You have designed the vessel and give it to the fabricator. The fabricator has to find dish manufacturer with 60 to 70 mm thickness of hemispherical dish. If the dish forming facility is not available in your particular area, the travel cost will be increased. Otherwise, you have to search the dish forming person in different countries, means the expense will be too much. For that, you can able to design the higher strength material, and you can able to reduce the thickness of the material, so that you can able to find a fabricator which is near to your shop. So that will save some amount of money which you have spent for the materials. So you have to be very wise during material selections. Okay, I already told that the temperature selection matters. Why? Because of the high temperature materials requires higher thickness. If the vessel has to withstand highest temperature, then the thickness of the material has to be increased. And in another hand, if the vessel has to be run in lowest temperature, the brittleness of the material has been increased. So we have to choose the material accordingly. High temperature material requires any alloy material, just give alloy material. But before giving any alloy materials and avoiding CS materials, you have to confirm once, twice, or thrice. You have to confirm that. You have to refer the previous projects, because you are skipping a major step from CS to alloy. So you have to be very careful during those kind of designs. Now we will discuss about the common mistake which all the static engineers do during their early stages. Choosing based only on strength. Actually, if you have chosen a material based only on strength, we have to think about the practicality of the material. We have to think about the fabrication standard of the material. Can be able to weld that material? Can be able to form that material? All this you have to consider. Just take one example. If you are using a high carbon steel material, the high carbon steel doesn't withstand the weld. If you are welding in the high carbon steel material, it will crack easily. So high carbon steel means it will provide extremely good strength, but the weldability is zero. We can't able to weld high carbon steel material. So you have to be choose very wisely in the strength selection of the material. Ignoring design temperatures. Normally what we will do is we will take a material. Normally in initial stages what we will do is we take a material and we know the allowable stress of the particular material in the room temperature. If it is SA516 grade 70, the allowable stress will be 138 MPa. So we directly take the 138 MPa and we calculate and we provide the output to the manufacturer. But that is wrong. We have to consider the design temperature of the particular material and we have to pick the allowable stress for the particular temperature of the material according to ASME section 2 part D. And confusing with ASTM and ASME, sometimes we order the material as A516 instead of SA516 grade 70. Actually the both material are not same, almost same only, but both are from different standards. A means it is directly coming from ASTM, SA means it will be coming from ASME. So if you are providing the mill test certificate to authorized inspector as A516 instead of SA516, the authorized inspector will ask you why it is A516 instead of SA516, why you have purchased the material in ASTM standard instead of ASME standards. Those questions will be arrived. To avoid that question, you have to be very careful while choosing the material and while purchasing the material. And we have came to the end of the video. Now it's time for final takeaways. ASTM defines the material, ASME approves them for the vessel. There are many materials in ASME. The ASME are defining the material, what is material for, how this material can be used, what is the chemical properties. Those things will be listed in ASTM, and ASME is approved for the vessels. We can able to directly use the ASME materials for designing a vessel. SA material is ASME adopted version. We can directly use the SA if the material starts with SA516, SA106, SA105. We can directly use that material in pressure vessel calculations without any worries. Unit differs. Most of the time you can able to confuse with the M and without M material. If you are designing a vessel for SI units, for metric standards, use the M version. If you are designing a material for customary units, use for SA516. It's a direct SA516 materials. Okay. And finally, the material selection depends on temperature, stress, corrosion and fabrication. How we can able to fabricate the material, how much corrosion is the material going to face, how much stress is there for the particular vessel, and what is the temperature of the vessel. This everything we have to consider during picking a material for pressure vessel. Okay, next video we will discuss about thickness calculation. I think directly jumping into thickness calculation, directly jumping into ASME UG 27, is it okay, or if you need the detailed version, like you need to know about U2, U2G, or you need to know about the previous classes of ASME, please mention in comments so that I will skip the thickness calculation now. Okay, bye.